welcome to another video. And in this video, we'll be creating an application in Golang, simple application that will leverage Netlify, and specifically it will leverage the Netlify static sites and Netlify cloud functions. And database will be hosted on Torso, which is a LibSQL database, and it's hosted on Torso. And we'll be using htmx on the front end side for creating or sending requests for various sorts of operations that we'll be doing in the application. So let me first show you the application itself, which is a simple CRUD application. So if I go to link it, dev.netlify.app. So this is just a simple htmx tailwind static site, and it is fetching the database queries and rendering them in a HTML response back from the server. And so that is one. So let me show you all the operations that we can do over here. So I can add a new link, so it will create a form for me. So let me add how https works. So this is one really cool uh, website to learn HTTP works, how HTTP works. So I just copy this link and add it over here. Add it over here, and I just have some commentary or my thoughts on this, how good it is or what actually it is. So I just add this. We can add a little more, but this is just for sake of it, and we'll create it, and you can see it has created the site. I just need to reload the site, and it should be within the all the list posts over here, and you can edit. Highly recommend. So just save it, and that will just save it. And if you want to delete this, it just gets instantly deleted. So that is the application that we will be creating. This is hosted on Netlify. We can host somewhere else as well. Uh, that is that we can host it on GitHub pages or any static site hosting provider. And so let me show you what the flow would be like in this case. So here we have static files and templates, right? And the second component is Netlify cloud functions, which I have written in Golang. You could write in, I think, in JavaScript as well, TypeScript. And the third component is the database, LibSQL database, which is hosted on Torso. It could be any database, but I'm just sticking with LibSQL. It is really free and it is really amazing community. So it is a really interesting database to watch out for. So here, let me go through the flow, which is first we have static files and templates. So this will be hosted on Netlify or any uh, static site hosting providers, and this will have some HTML files, and this will get rendered on the request. And static sites will have some links that will have these links like add new link or edit or delete or save the post. So this will trigger an HTTP request. Those are inside of this template, and this will request the Netlify cloud function that will be hosted on Netlify. So we can have various types of requests, that is get, post, patch, and delete, and those will be served from htmx by http. And once we receive it over here, we'll be sending a SQL query to the database, and that will have some tables and rows. So it will fetch those out and return the rows, and inside that we'll again process the response and send the HTML response. So we send the HTTP request and we return a HTML response. So we just swap out the things that are rendered on the page, on the HTML page. So that is the flow that will be uh, making this application in. So let's get started by creating the Golang application. So first so let me initialize the Go model. So we can say Go mod init github.com with the version control name, the username on that version control provider, and let's call it link blog. and that is that. So now we have created the Golang project. Now I need to install a few things. So let's first set up SQLC, which is the tool that I'll be using, which is, let's show it. So SQLC is just one tool that can convert like SQL into type safe code, which could be any language. It could be Golang, it could be JavaScript, or it could be any other language. So it is really handy to create some boilerplate code, which we create for CRUD applications, like create queries or like insert queries, list or select all queries, or delete queries. So those kinds of things really work well with SQLC. So I'll be setting up this. So I have SQLC on my system, but I also need to use it on this project. So I'll just say, I just go get github.com SQLC dev SQLC/cmd latest SQLC latest. That will install me that, and so I'll do go mod tidy. That will, so right now we have not used it, so let's not do that, and let's create. So So let's create the settings for SQLC to set up. So we'll do version go2, that is the latest version for setting this YAML file. I'll use the SQL settings for this. So engine is SQLite because Torso is like SQLite and not, so it is very compatible with SQLite. So that should be good. Then the queries, I'll call the queries file that will be residing. So let's call it query.sql, and yeah, it will, so we'll call it schema.sql. And for the generation, that is how do we want the settings to be looked for when the code is generated. So for Golang, the packages will be called models, and where it will output is again in the folder called models from this current directory where we'll run sqlc command from. So once we do that, we also need to add emit JSON tags that will be used to kind of identify which fields to ignore or which fields to get into the actual structure or the object or the instance of the data that we are fetching from the database and populating it accordingly. So JSON tags will just add the tags that we'll have in the structure. So this is really adding those kinds of tags and names for that. So we'll set it to true. Once we have that, I'll just change this to be query.sql and schema.sql, but it could be inside of any folder you wish to create. So that is it for this setting. And let's save this. And now let's create a schema.sql, which should be pretty simple. So for the schema, we just have one table. So let's create a table if it not exists, because this is important, because if it, we are running it on cloud functions and we will be running this file again in, every time the request comes in. We can avoid that, but just to be safe, we are using uh, we will be running this schema.sql file to the generation again every time we hit the endpoint. So create table if not exist links. Let's call the table as links, and we'll have fields like ID, which could be an integer, as a primary key, and we will set it to auto increment to or like add up the IDs every time we create the new record. And then the URL, that could be a title, but let's just keep it text, and it could be, it should not be null because that is the requirement for the title to be present. And commentary, it could be just content, so it is text, and it again cannot be null, so let's keep that as it. So that is the schema for this project. We will be adding up in the next video where we will have user and authentication for this creation of links and other things in the blog as well. So this will be expanded on the later part of this series. But for now, let's just keep it simple and have just one table with link called as links, and with the fields like ID, URL, and commentary. So this is the basic uh, fold, table for this this project. And let's now create a query.sql. So this will contain all the queries. So let us now create a query which will be used to sort of get us the CRUD functionality using the database. So this will basically run this query and also generate. So we don't want to execute these queries as just as it is, right? We need to have some sort of type safety for this. So we will create this query.sql file which contain all the queries that we want to run, and it will generate a Golang code, which is some boilerplate code that we'll use to set up the structure appropriate for running these queries. And we will just have functions at our end to grab or to operate or to perform any operations on these tables using these queries that we'll create. So let me show you first example, which is to create link. So this will just the we can say the post request, or we can say create functionality into it. So this is the name that we want the function to be used, and the return type should be execute, and so that is execute exec and last id. So the return value should be the last like last inserted id into this query. So if we create the link and that is successful, then we will return the id that is for that created record or the link. So we'll now write the query, that is insert into links url commentary, and the values will be placeholder values that will be fetched from the actual method that we'll be calling. And let's now do the other operations, that is the name. So this will be the other operation, that is like getting individual links or listing all the links, updating or deleting the links as well. So let's create a get link which will fetch one link. So the return type will be one, and we'll select ID, the URL, and the commentary from links, where ID is the placeholder value. So the ID equal to question mark, that the question mark will be the placeholder that will be fetching from this function parameter. And let's add get links by URL. So we'll have many instances of this. We will not be using this, but let's have it anyways. So this will be select ID, URL, and commentary from links, where URL is question mark. So if we want to get all the links or all the commentaries on the links, we can just fetch. We can fetch all the all the like posts, we can say, with the same URL and list them as a many. Now we want to list links. So this again, the return type will be many, and select ID, URL, commentary from links. So this will return all the links and order by ID. So this is just a regular list method. And now we'll try to delete the link. So it will just execute it, because after we delete, we should not return anything ideally into it. So delete link will delete from links where ID is question like the placeholder value, which will be the ID of that post that we want to delete. So now the last query is remaining as update link. So this will be just executing it, because we already will have the ID when we are updating the link. So update links, set URL equal to question mark and commentary to question mark. So that is, we are updating the URL and the commentary where the ID is given as a placeholder. So remember, here we are not updating ID, we are just updating URL, commentary, or whatever we have been updating in this. So this will update all of both of these values. Like those could be the same values, but if the user has explicitly changed them, then it will be changed on the both the fields, but ID will remain the same. So that is it. These are all the queries that we'll be using in this application. And so now let's use now generate the code. So as you can see here, right now we have uh, 5 files, that is go.mod, go.sum. These are generated by Golang itself for the module. And then we have created 3 files, that is query.sql, schema.sql, sqlc.yaml. So query.sql and schema.sql contain the actual queries and the schema for the database, and sqlc YAML is just a configuration for the sqlc to generate the code for us. So now I'll just call it sqlc generate, and now you will see that there is a models folder created. So let's look into the models folder. I'll open it over here, and you can see the models folder has db.go, which is just a connection to the database that we want to make. Models will now create this like a, a structure for the model that we for the table that we created, that is link, and the fields are id, url, commentary, and you can see the json like the JSON tags are created. So that is why we wrote this emit JSON tags is true. So this will sort of generate the JSON tags for this. So it becomes handy for us to get the JSON tags for that and also use them in later stages. So it has set the types accordingly, int 64, string, and string. And query.sql will contain all the functions that we want to run. So this is, you can see, create link will take in the link params. That is the structure that will be used to create this link. That is the URL and the commentary. So we'll pass this, and it will create this link with the query that it is created here. So likewise, we will have this delete link, get links, and all of them. So this will be quite handy because we don't have to generate it again and again. So this is just boilerplate code that is generated by SQL C. So that is one thing. And now let's go to the actual application that we'll be running. So let's call it main.go. And here we need to like create a few things that will be used throughout the applications or inside the Netlify functions as well. So we will be using Netlify functions as we discussed. That is, it will accept a request, and in that request we might have the body if it's a post request or a update request, and with that body we need to pass that body and like create or update the database accordingly. So now we need to create the main file, which will be like a module, or we can say a package in this essence that we'll be using later on while creating Netlify functions. So this will be a, a file that will contain all the necessary things that we need to make sure that the Netlify functions are compiled correctly. So I'll create a package main. So this will be just so if I call it the module, so that this will be the name of the module. And if I want to import a few things, then I can just use package main for importing all the necessary things. So I'll embed library, that is a functional library. And why I need this, because I need to embed the the schema.sql file into the Netlify cloud functions for executing those queries every time the request comes up, or we need to connect to the database and make sure the schema is proper. So I'll create go embed. So this is a special tag, or we can say like a declarative directive, that is, it should be like it will embed that uh, file, we can say file, or any piece of like any piece of thing into the variable that we will specify. So embed, so we are specifying the schema.sql file to be embedded into ddl variable, which is a string type. So what this will do is take the contents of schema.sql and dump it into ddl variable. So why I'm using this, because we need to now create Netlify functions, cloud functions. Those will be used to connect to the database, and every time we connect to the database, we need to make sure that we are running the queries or the schema, so that it is like it is very recent, or it is up to date with the current changes. So now let us create so now, at least from the this perspective, we have main.go file added. So now let us create another folder called netlify slash functions. So I'll add mkdirp netlify functions. So this will create a netlify functions. Inside of that will be a functions folder. And now let us create another folder with the name of this function that we need to make sure that Netlify picks it up. So I'll call it Netlify functions, Netlify slash function slash API. So if I go to, let's say, uh, if I go to linkit.dev slash not netlify.app, then dot netlify slash functions and slash the whatever the name of this folder will be, that will be served as the cloud function for this for this project of Netlify. So I need to create the API folder, and inside of that I can now create a main.go. This will be the entry point. Not necessarily should be main.go, but it could be any name. But the essence is this Go file should be the entry point for the slash API route on the Netlify functions directory, the URL. So once we have this, now we need to write the actual Netlify function code. We are in the Netlify slash function slash API and main.go file, as you can see over here. So I'll just close this window now, and let us start with the implementation of this function. I'm just gonna have one iteration of this, and then we can add the rest of the code. So for now, let's import a few things, and we'll need to create a queries. So these are the queries that we will be using as object from the program. So now we have not imported this package. So let me just install this. So go get, that is added. So now we need to import models.query. So now what is models? So we have now a model folder, right? That was the generated code from SQLC. Remember, as we have specified it over here as well. So that will be the model that we'll be using over here. So model.queries, if you want to see it right again, I just reiterate. So models.go will have a queries or like a context over here. So you can see it is fetching from the dbtx, which is database transactions, and over here we can see it is the interfaces for getting the rows or preparing some database related information. So that is that. So this will be used for querying the database, and we can access this database object and then use those methods, that is the queries functions that was generated to query the database. So this will be the thing that we'll be requiring as a global, and then we'll import the models for this uh, import that we have done. And now we need to import the lambda as well, so which is uh, AWS lambda go like package that is used for like creating this Netlify functions, as Netlify Go functions are AWS lambda compatible. So we need to import that, and we'll be good to go with that. And we'll import the lambda, which is a thing that actually helps us start the function. And so lambda.start will call this function that will, so we need to pass in a function over here id, so that will actually uh, update that thing. So now it should be hopefully visible to it. So yeah, so it takes in the handler, which is an interface, and that is how we will be passing this handler function. So now we'll call this handler. This is the function. So it has an interface. So we'll need to the two parameters that will be used as a interface. So handler function implements on the interface. So the interface is something that we pass it as as the parameters. So the request is of type events dot request context. So API gateway proxy request. So events is the like sub module for this AWS Golang package. So we'll import it that, and API gateway proxy request. So that is the incoming request that we will be receiving from this function. So we'll be able to access the request that will be coming via this cloud function. And this function also returns the API proxy response, and or it will respond with the error. So that is the handler interface that we need to implement. And let's see how we will leverage the request and send in the response. So first thing we need to do is provide this context. So this will be used for running the database, like in the queries or schema migrations. So I'll first need to connect to the database in order to run the queries. So first we'll provide the DB name, which will be fetched from the environment variables DB underscore name, and DB token will be fetched from, again, from the environment variables DB token. And we need to now construct this DB string that will be used for connecting to the LibSQL database hosted on Torso. So I'll just provide the LibSQL protocol, and that will be percentage s for the DB name, and query parameters will pass the auth token again as the placeholder, and so we'll pass the placeholder values, so DB name and DB token, in the respective positions. So this will construct the DB string for us, and now we need to import a few things. So SQL.open, so this will be used for operations on the database. SQL is just dialect, so we'll open the connection using this libsql driver and the DB string as the actual path to the database. So SQL.open will basically give us this DB object in the SQL.db driver like object, and the driver name is libsql. So that is how we will be able to connect to the database. It could be a local database, or it could be a cloud, or anywhere it's hosted on Torso. So this is one way to connect to the database and a DB string that we're providing over there. So now if there's error, we just log or like respond it with some response. So now we'll be leveraging the response. So we'll return events.response status code 500. We can have some message, but we'll see it in the later stages. But for now, let's just keep it simple and return with the error as well. Now at the very end of this function call, we need to close the database connection so that uh, it doesn't leak any memories, or like there's safe operations performing over there. And now we will fetch all the queries. So this was just initialized, I should say, and then we need to create a new instance of this db, new instance of this dbtx context, and we will pass uh, the, the db instance that we have connected recently. So that will be that. And if there's an error with this, so now we'll execute context. So this will basically uh, perform all the queries that we want to, and we pass in the context. So that's why we need the context variable that we initialized earlier. So that is that. And now we pass the data.ddl. So what is this data.ddl? So well, that is, so data we have, I'm calling it data, but it could be a little better name. So what data is, it is just like a package that we are created recently. So here main.go was the package, and here you can see we have created this ddl variable which is of type string, and it contains the dump of this schema.sql file, which was just a, just a schema for the database. And now we'll be using this ddl to actually query the database. So this will take in the raw queries. It is the raw string queries, as you can see over here. Query as a string and the argument that will be required over there. And if that, so we'll run this schema every time we come up with this request. So that is important because we need to make sure the database is updated and not breaking any changes. This could be handled very differently as well, very safely, using like uh, using Goose or any other migration tool that we might be using. But for now, let's just keep it simple. So if there is an error in context, like in executing the queries, we'll just log those out, and will optionally return the response with status code as 500 and the error. Returning error might not be very secure, but yeah, we can add error as well for now. And at the end, for now, I'm just returning with the response uh, status of 200. But in the later stages, we can just add the actual things that we want to return. But this is just uh, like a warm up thing, I would say, like just to clear up things what we are doing over here. This is just a boilerplate code for connecting to the database and just responding with uh, a response, right? So this is just one quick little thing to make sure that the API is working. It is a little complaining about what we have done here, but let me just save the file and it should be good. So we have used that and that should not be an issue. So it says is a program but not an importable package. All right. So actually we should not name that package as main maybe. So that's why we need to create this in a separate folder. Let's call it not utils. Let's call it embed SQL. Sorry. So let me create a folder called embed SQL. Okay, and we'll copy all of these files. So first we'll copy this in a query schema and the query SQL.yml as well. So why I'm doing this, because here we still need to keep this schema.sql. We cannot go backwards and call this as that. So we'll do embed SQL. So now this will be the module name, and this will mess up a little things because now we need to keep all of these in a single package. Like we need to copy schema.sql file every time we make changes, but we'll keep the main file as it is. We don't want any other things from here, and that should be it. And we need to make changes from here, so let's call it embed SQL. So once that is there, we will call embed SQL, and that will be available to the function as well. So let me restart JavaScript again once it is cleared. I represent this embed, so that will be embed SQL, and so that should be it. Yep, there are no more errors, so that is working. So now let me test out all of the changes that we have made. So let me initialize this Git project. Git. Let's change the name of this domain, and let's add. I think we can add everything over here. So let's commit. I'll just add my name to this. I can do this via CLI, but that is very weird to do. So name, I'll just keep it. Do I will do it this way, or I'm really not sure. So I'll just add my username and mail, and then I need to create a repo on GitHub. So let me gh repo. So is it gh create repo or repo create? I guess it is repo create. So gh repo create. I like to create existing local repository to GitHub. A new repository to GitHub. So repository name will be link block. Description. Public. I don't want this. Not license. So yep. that will create that. I don't want to clone the repository because it is already there. I just need the URL. So I'll just get remote add origin. So now let us go to that file. So I'll call it link blog, right? So let me copy the SSH link and let me push this to. Oh yeah, obviously. So let's push origin main and that should be, yeah, so there it is. And now we need to do a few things, which is to create a torso database first. So let's create torso. Am I logged in? So let me do, I think it is auth. Who am I? Yeah, so I'm logged in and let us create torso. Is it db or is it create? db create. And what can we do here? Okay, we need to specify the group. Let me open the torso dashboard here as well. Torso, I think let's list all the things that I have. So db list. So I have all of these files and I want to create this as a group. So let me do group demo projects. Okay, so it has created content salesman. Let me go over here and let us go to torso. I think it is app.torso.tech. And you would see over here we have an empty database created at first. Not able to go there maybe for some reason. Yep, the demo projects. And you can see that is just created right now. There are no links over here. So now what we need to do is we need to create the token for it and then just store it over here. So let me call this env. Let's just create it over here and we'll say db token and we will have db name. So here we'll just copy this. I'll just remove the libsql because I've already added that. And now we'll create the db token. We can edit via here. Sorry, from here. Let us create token, or we can do it from CL as well. Let me show you over from the CL as well. So db tokens create content talisman, and that is the token for us. So this will be a little weird to paste in here because it will. Anyways, so yeah, that is the env files that we have created, and now so we have already configured this. Now let's go to Netlify and create the project. So let me log in here. I think I should be already logging. So yeah, now I'm logging. And now let me add a new site. So let us import an existing project because we already have this project on GitHub. And now think we can list, or I need to provide the access to this. So I'll configure, uh, so I need to configure this. I'll select the repository that I want to add. So let's call it link blog. Yeah, there we go. And let's add it into Netlify. So link block, and we need to deploy the branches. So we'll just keep this everything default, but we'll add in the environment variables here. So let me call it db name, and let us copy it from here, and db token, let's similarly copy it from here. Okay, so that is added. Now let's deploy a link block. I'm just keeping everything in default. You can change it if you want. So deploy a link block, and that should hopefully do that. I think it is done. I think it's just saying that running incognito. So let me open this here. Has it not created that? And hopefully, yeah, that is now created. So hopefully we don't have any static sites yet, but we do have one function that will get deployed using this script. So let's see how well that goes. So while it is getting deployed, let's look at the site configuration and change the site name because it is quite weird. So let me call it link blog dev. Save, and that should be it. So let's see over here. It is still in progress. Now it has been building. So let's initialize and build. Okay, it has failed. Oh, I know why it failed. Yep, yep. So let me add one more variable, which is the Go version. I forgot to add that. So let me add one single variable called Go underscore version. And the value will be 1.23.3 because I am using this 1.2.3, 23.3. So I'll just create the variable and let's deploy it again. So we can trigger the deploy from here. And that should be starting up soon. So it has started the build and it has picked up the API slash main.go, which is the function that we want to deploy. And hopefully that build will be successful. And yeah, so one function has been deployed. So if you go into deploys, sorry, logs, you can see the functions here, and you would see functions being So let us go to this. So in this way, this won't have anything. But if you go to Netlify /functions/API, it doesn't respond anything, which means it has been successful, I believe. But here I'm not able to see the function somehow. Yeah, here we can see now. So here you would see that it has have some logs here, but we don't have any active logs here. But you can see this is actually working. Let's see the network tab and let's load this. So you would see over here we have responded with 200 and the response should be empty because we have not responded with anything. So that is working. And now let's go into the. So that is it from this part of the video. We'll see in the next part how to create the CRUD application. That is, we'll add templates and create the remaining methods, which are create, that is post, update, which will be put, and delete. So we'll be seeing how to create this API end to end.